Bismillahirrahmanirrahim. Assalamu alaikum. Today we will do Thomas Calculus, 12th edition, chapter 1, functions, section 1.1, functions and their graphs, graph of functions, and example 2. Graphs of function. If f is a function with domain D, its graph consists of points in the Cartesian plane whose coordinates are input-output pairs for f. In set notation, the graph is x, fx such that x is element of D. The graph of the function fx is equal to x plus 2 is a set of points with coordinates x, y for which y is equal to x plus 2. Its graph is a straight line sketched in figure 1.3. If we look at figure 1.3, we see that the graph of f of x is equal to x plus 2 is the set of points x, y for which y has the value x plus 2. Y is equal to x plus 2 tells us that the gradient is 1 and the y-intercept is 2. The graph of the function f is a useful picture of its behavior. If x, y is the point on the graph, then y is equal to fx is the height of the graph above the point x. The height may be positive or negative depending on the sign of f of x. Figure 1.4. Figure 1.4. If x, y lies on the graph of f, the value y is equal to fx is the height of the graph above the point x or below x if f of x is negative. If we study figure 1.4, we see that at x is equal to 1, we get f of 1, which is a positive y value. At x is equal to 2, we get f of 2, which is also a positive y value, but f of 2 is less than f of 1. If we look at x, f of x is negative. Example 2. Graph the function y is equal to x square over the interval minus 2 to 2. Solution. Make a table of x-y pair that satisfy the equation y is equal to x square. Plot the points x, y whose coordinate appear in the table and draw a smooth curve labeled with its equation through the plotted points. See figure 1.5. If you look at the table, at x is equal to minus 2, y is equal to 4, at x is equal to minus 1, y is equal to 1, at x is equal to 0, the y is equal to 0, at x is equal to 1, y is equal to 1, at x is equal to 3 over 2, y is equal to 9 over 4, at x is equal to 2, y is equal to 4. If we plot all those points on the graph and join it with a smooth curve, we get figure 1.5. How do we know that the graph of y is equal to x square doesn't look like one of these curves? In this figure, the graph is connected by straight lines between the points, and in this case, the graph is plotted by wiggly lines between the points. To find out, we could plot more points, but how would we then connect them? The basic question still remains, how do we know for sure what graphs look like between the points we plot? Calculus answers this question as we'll see in chapter 4. Meanwhile, we will have to settle for plotting points and connecting them as best as we can. Thank you for watching. Allah Hafiz.